Let's talk about something every developer eventually faces, but no one really explains properly: production. Your code works, you tested it, everything looks perfect, and then you deploy it, and suddenly things start breaking. Users report bugs, performance issues appear, alerts start firing, and you're left wondering what actually went wrong. And that's when the most common line shows up: "It works on my machine." So let's simplify this in the easiest way possible. Production is where your code leaves your local environment and runs in the real world. It's no longer just your code anymore. It's something real users depend on. It handles real data, real traffic, and real business impact. This is the stage where your application is truly tested, not by controlled test cases, but by unpredictable, real-world usage. Now here's the first important concept. Users are unpredictable. In development, you think you understand how your application will be used. You design flows, validations, and test cases based on expected behavior. But in production, users don't follow your expectations. They enter unexpected data. They use features in ways you didn't design, and they create edge cases that no test scenario could have covered. Even the best test data cannot match the diversity and messiness of real-world data. Now let's move to the second problem: the environment itself. Your local setup is completely different from production. On your machine, you might have a specific operating system, a certain database version, limited data, and almost no traffic. In production, everything changes. You have different operating systems, different configurations, massive data sets, network latency, and thousands of users accessing the system at the same time. Even small differences like library versions or system resources can cause your code to behave differently. This is exactly why "it works on my machine" happens. The code works in one environment but fails in another, because the environments are not the same. And unless you understand this gap, you will keep running into the same issue again and again. Now let's talk about something that makes this even more complex: scale and load. When you test locally, you might click a button a few times to verify functionality. In production, thousands of users might click that same button at the same time. Suddenly, your system has to handle concurrency, database pressure, memory usage, and performance bottlenecks. What worked perfectly in isolation can fail completely under load. Another important factor is external dependencies. Your application rarely works alone. It depends on payment systems, email services, authentication providers, and other APIs. In production, if any of these systems slow down or fail, your application is affected. Even if your code is perfect, the system can still break because of something outside your control. And then comes security constraints. In development, things are open and flexible. In production, everything is locked down. Firewalls, HTTPS requirements, access restrictions, and security policies are enforced. Something that worked freely in your local environment might get blocked in production because of these restrictions. So the question is, how do we handle all this? The first step is reducing the gap between development and production. Strong engineers aim for environment consistency. They use tools like containers to ensure that the same setup runs everywhere. They also maintain staging environments that closely resemble production so that issues can be caught early. The second step is observability. In production, you cannot rely on debugging like you do locally. You need proper logging, metrics, and monitoring. Logs help you understand what went wrong. Metrics show how your system is behaving, and monitoring helps you detect issues before they become critical. Without these, you are essentially blind in production. The third step is automation. Manual deployments are error-prone and stressful. There are too many steps, and missing even one can cause failure. That's why we use CI/CD pipelines. Every change goes through a structured process where the code is built, tested, and deployed automatically. This ensures consistency and reduces human error. Now let's talk about building production-ready code. One of the biggest mindset shifts here is understanding that production readiness starts during development. It's not something you fix at the end. You need to think about performance, error handling, and security from the beginning. Performance is not just about speed. It's about user experience. This includes optimizing queries, reducing unnecessary network calls, using caching, and loading resources efficiently. Your system should not just work, it should scale. Configuration is another critical piece. A common mistake is hard-coding values like database connections or API keys. This works in development but fails across environments. Instead, configuration should be environment-specific. Things like database URLs, logging levels, and service endpoints should change based on where your application is running. Sensitive information should never be stored in code. Instead, it should be managed using environment variables or dedicated secret management systems. This improves security and makes it easier to update values without redeploying the application. Feature flags are another powerful concept. They allow you to enable or disable features without deploying new code. This helps in testing features with a small group of users, rolling out changes gradually, and quickly turning off features if something goes wrong. Now let's move to error handling and logging. In development, we often focus on the happy path, where everything works perfectly. But in production, failures are normal. Systems break, dependencies fail, and unexpected scenarios occur. That's why proper error handling is essential. Instead of crashing, your system should handle failures gracefully. If a feature fails, provide a fallback. If an API is down, show cached data. If something goes wrong, give meaningful messages to users instead of technical errors. Logging plays a huge role here. Logs should capture what happened, when it happened, and why it happened, but they should not include sensitive data like passwords or personal information. The goal is to have enough information to debug issues without creating security risks. Now let's simplify everything. Production is unpredictable. Users are unpredictable. Environments are different. Systems operate under real pressure, and that's why writing code is not enough. The real goal is to build systems that can survive in the real world. So always remember this. Your application might pass all tests, work perfectly in development, and still fail in production. Because production is not just another step, it's the reality your code has to face. And at the end of the day, your users don't care if your code works on your machine. They care if it works on theirs.